some vocabulary, which again, you've seen these last year, but if you forgot, no big deal. Radical is a fancy name for? The silence overwhelms me. For a square root. Radical, square root, exactly the same. So for example, we could call this the square root of 12. We could just call it the root of 12, or we could call it radical 12. Which a little bit of history you don't need to know, but where this symbol comes from is originally way back when they used to write it as an R. R meaning radical. And so then eventually they kind of put the tag on the R. They eventually kind of got a curvy R, which eventually morphed into what you see now. So it was actually just originally an R, R for radical. Another example could be the square root of 6, which we could also say is root 6. I'm going to box that, radical. Yes, sir? Generally, when there's two different words in math, one tends to be North American, one tends to be European. And there's something when the Europeans brought the math to us, there's something in the vocabulary that changed. So we say square root, they would always say radical. So radical is kind of more universal because more people know it. We just really like the word root. Perfect square, you've seen these numbers since grade 7, nothing new here. A number that has a something square root. So what is a perfect square number? Can you give me an example of a perfect square number? Andrew? 4 is a perfect square number. Why? When you take the square root of 4, what is it? 2. Okay, so what kind of number is 2? I think I might have heard it there, Cody. Whole number, you got it. And whole number just means there's no decimal. Give me another example of a perfect square number. 25, good example. 25 because the square root is 5, even, no decimal. Give me another example. 121, I heard, because the perfect, or the square root is 11. What about, for example, 27? No, we'd call that a non-example. Why is 27 not a perfect square? Yeah, because the square root would be 5.1, 5.2, so there's a decimal part to it. Some vocabulary. Radicals are made up of 2 parts. We have what's called the radicand and the index. Radicand is the number under the root sign. The index is the number outside the root sign. So the x, the number underneath the root sign, is called the radicand. The little n is called the index. And this is where things are going to change from grade 9. In grade 9, we only did square roots. We stopped there because you weren't smart enough. Now we're going to add other things in square roots. What else is there besides square roots? Cube roots and fourth roots and fifth roots. We can put absolutely any number that we want here. If there is no number, like here with the root 12 or the root 6, what do we assume it to be? 2. Okay, so if there's no number, we assume it to be 2. That's called a square root. Anything else, we would put a number there. So some examples is we're just going to change these into radical form. How would we write mathematically the 5th root of 65? The 5th root of 65. Well, we have 5 and we have 65, which is going to be the index, which is going to be the radicand. Radicand is going to be 65. Index is going to be 5. There's how mathematically we write the 5th root of 65. Why do mathematicians love symbols so much? Why do we hate words? Easier to remember, simpler, yes, more specific. Why do we like symbols better than words? Because the words depend on language. So to understand the words, we all have to speak English. If I just showed this to a mathematician who didn't speak English, say they're from India, they're from France, they're from China, are they going to understand? Absolutely. That's why we like symbols so much, because it's not language dependent, we call it. The cube root of 4, what is the radicand going to be? 4. And the index is going to be 3. That's called the cube root of 4. What does that mean, the cube root of 4? Something times itself equals 4. That's what it means. What does the fifth root of 65 mean? A number times itself times itself times itself times itself that equals 65. The 26th root of 42, write that down in radical form. The 26th root of 42. What's the index going to be? And the radicand? 42. What does that mean? A number times a number times a number times a number. How many times? 26 times, that gives you 42. So is it going to be a big number or a small number? It's got to be a pretty small number. Now we're just going to go backwards. So given something in radical form, you're going to give it to me in words. First one should be easy because it's what you're used to seeing. These are the kind of roots you saw last year. How do we say this in words? The square root of 102. Here's what's new in grade 10 pre-cal is we're adding in these roots you haven't seen before. So you've probably never seen a 7th root before, etc. So we would call this the 7th root of 51. The 7th root of 51. Write down the last one. Turn and talk. Share with someone just sitting around you. What did you write down? Whoever didn't just talk, tell the other person, what does that mean? What does it mean? So most of you have the 10th root of 5. What does it mean?
Number times itself 10 times.
Big number or small number? Small number. Here's the table that you need to know. The white squares you need to memorize. Whatever's in gray, you'd be able to use a calculator for. White squares you need to memorize. Gray squares, you'd be able to use a calculator. I'm going to do the white squares in red. And all we're going to do is calculate squares and cubes and to the 4th. So we'll start with the squares. These you've known since grade 7, so nothing new going on here. But 1 times 1, so 1 squared is? 2 squared? 3 squared? 4 squared? 5 squared? 6 squared? High five to Drew, you're on fire here. 7 squared? 8 squared? 9 squared? And 10 squared? Cubes, you got to think a little bit. You haven't really done a lot with cubes now. So again, the white ones you need to know. The ones that are in gray, you'll be able to use a calculator. 1 times 1 times 1. Well, that one's fairly easy. 1. 2 cubed. So 2 times 2 times 2, not 6. So 2 cubed doesn't mean 2 times 6. It means 2 times 2 times 2, which is 8. 3 cubed. So 3 times 3 times 3. So 3 times 3. 9 times 3, 27. 4 times 4 times 4, so 4 times 4, 16. 16 times 4, 64. 5 times 5 times 5, so 5 times 5, 25. Now, I always think about it as how much do you have if you have 5 quarters? 125. We'll grab our calc in a sec, so let's just skip to the 10. The reason you need to know the 10s is because they're super easy to know. The trick is the number of zeros correspond to the exponent. So when it was squared, it had 2 zeros, making 100. When it's cubed, it has 3 zeros, making it 1,000. Okay, using your calc, fill in 6, 7, 8, 9 cubed. Where's the exponent key? Lots of people showing me with their hands. What's it called? We call it the hat is kind of its nickname. What's its formal official name? It's called the caret. Caret. It's like the little V. It's on the right-hand side of the calculator near the top. Okay, so caret's its formal name. Hat's kind of its nickname. Just the cubes, yeah, we'll do the fourths in a second. Somebody have an offer for 6 cubed? 216 is the offer, confirmation. Okay, 7 cubed? 343. Okay, 8 cubed? 512 is the offer, confirm. And 9 cubed? 729, confirmed. Okay, I'm going to go back to red for the white squares. 1 to the 4, easy peasy, 1 times 1 times 1 times 1. Like, don't everyone show it at once. 1 to the 4. 1 was painful. 2 to the 4, so 2 times 2 times 2 times 2. What I do is I group them, so I do 2 times 2. 4, and another 2 times 2 is 4. Put them together, 4 times 4, 16. I do the same thing with the 3s. I group them, so 3 times 3, 9, and another 3 times 3 is another 9. 9 times 9, 81. Moving along to the 10s, 10 to the 4. So 4 zeros is going to be 10,000. Fill in the rest from your calc. Everybody's figured out how to do exponents on their calc. 4 to the 4. 256 is the offer. 5 to the 4. 5 or 6 to the 4. 1296, confirm. Oh, it's frozen. Oh, you can't see any of it. Not that you can really see it now because it's dark, but 7 to the 4. 2,401, confirmed. Okay, 8 to the 4. 4,096. And 9 to the 4. Ooh, that was in stereo. I like that one. That sounds confirmed. Okay. White ones you need to know. Gray ones you'd be able to use a calculator. what we're going to do with this, the reason we need to know is here's a question from last year. So estimate the square root of 40. Okay, exactly what you would have seen in grade 9. So some roots we know, some we need to estimate. So what we would have done last year is we would have said, well, what's the perfect square that's lower than 40? What's the closest one but smaller than 40? So look at your squared list. What's the number that's closest to 40 but lower? So this would have had to have been bigger than the square root of 36. Oh, you can't see that. And what's the closest one that's the closest but higher? Who's the closer one? 49. So it would have had to have been less than the root of 49. Well, what is the square root of 36? 6. And what is the square root of 49? 7. And then we're going to get the decimal by just saying, well, which one is it closer to? Is 40 closer to 36 or closer to 49? Closer to 36, that means the decimal has to be less than 5. Well, let's estimate. So it's going to be 6.3 I would accept, 4 I would accept, 2 I would probably accept. Do you remember doing that last year? Okay. Now do you remember, now that you've seen it?
What if it's like in the middle?
Then it would be 0.5. And again, I'd accept 0.4, 0.5, 0.6. We're just estimating. Well, we're going to do the same thing this year, except now we're going to do it with cube roots and fourth roots and square roots. So that's why we just did the table before. So let's start. Square root of 30 would have been one you saw last year. Nothing new here. You're looking at the table. You're looking at the squared row, and you're saying, well, what's the closest number that's lower, and what's the closer number that's higher? So what's the closest perfect square that is lower than 30? 25. And what is the square root of 25? 5. So we know it's bigger than 5. What does it therefore have to be less than? 6. Well, is it closer to 25 or closer to 36? Closer to 25, so let's make an estimate, 5.4. I would accept 0.3. I would probably accept 0.5. Well, here's B, and this is what's new in grade 10 pre-cal. So you didn't have to do cube roots last year, Drew?
Would you accept it if we did like 2 decimal places?
Yep. We're just estimating. So unless the direction said to 1 decimal place. Okay, so now instead of looking at the squared row, what are we going to look at for B? The cube row. So look at the cube row. What's the closest number to 260 that's lower? 216. And what's the closest number that's higher? 343. Cube root of 216 is 6. Cube root of 343, 7. Closer to 216 or closer to 343 or kind of in the middle? Closer to 216, so let's estimate 6.3. I would accept 6.4. Who's getting this so far? Getting it, kind of getting it, not getting it. Good. Let's go to partner, and I'll give you a couple minutes to do C, D, and E together. I feel like you're ready to talk. Okay, fourth root of 17, you're looking at your x to the 4 line on the table. What's the closest one that's smaller than 17? So fourth root of 16, ooh, my pen's running out, which is 2. And what's the one that's closest but higher? Cube root of? I'm just hearing like mumble mumble. 81, which is equal to 3. Closer to 16 or closer to 81? Way closer to 16, so give me an estimate. 2.1 I would take, 2.2 I would take, 2.15 if you want to get fancy schmancy. Questions? Who had that one right? Awesome, good job. Fourth root of 30, what's the closest one that's lower? $16, so same one as before, which is 2. And the closest one that's higher, 81, which is 3. Closer to 16 or closer to 81? Still closer to 16, so 2.4 I would accept. 2.3 I would accept. Who got that one? Awesome. Last one, cube roots. You're looking at your x cubed line, closest one that's smaller. 27, which is 3, and the closest one that's higher. 64, that's 4. Is 60 closer to 27 or closer to 64? Closer to 64, so 3.9 I would take, 3.8 I would take, 3.7 I would even take. Show me your thumbs, how you feeling? Good. Wouldn't the last one be? But the 4 would be 64, right? Cube root of 64 is 4 exact, so it's got to be slightly under 4. I just wanted to add an example because last year this came up in the homework and people were like, what? Square root of fractions freak people out. Let's do, I don't know, square root of 16 over 64. And this one isn't an estimate, it's a perfect square. One of the questions is just do the square root of things. And for some reason, I don't think you saw this in grade 9 because it freaked people out. So when you have a fraction like this, the square root just applies to the top and bottom. So this is the same as the square root of 16 over the square root of 64. So we just split the square root. And then what's the square root of 16? 4, and the square root of 64, 8. And then if we reduce, we can. 1/2. Okay, so there's how to do perfect square roots of fractions. We just split top and bottom. No, in the homework there's only perfect ones. Time is yours, page 206. Just a reminder to send me an email about the seating plan or send me on a